You were told that a single AI agent would automate your entire job. Give it a prompt. Let it search the web, write the code, fix the bugs, deploy the infrastructure, and handle your customers. It sounds revolutionary until you actually run it in production. Within 10 minutes, your single AI agent gets confused. It forgets its original goal. It hallucinates a broken file path, gets trapped in an infinite error loop, burns through $20 in API tokens, and crashes. Why does this happen? Because one general-purpose AI agent trying to do everything is like hiring one person to be your CEO, software engineer, security auditor, database administrator, and accountant all at the same time. Single AI agents do not scale, and the industry is quietly moving past them. The future is not one super intelligent model. The future is an autonomous multi-agent swarm. To understand why single agents fail, look at what happens inside the model's context window. Every time an agent thinks, searches, reads a file, or executes a terminal command, that entire history is fed back into its memory. As the task grows longer, the context window fills up. The model suffers from attention degradation. Crucial system instructions get buried under thousands of lines of raw tool outputs and API responses. The agent loses its train of thought. It begins repeating failed steps. Worse, when a single agent makes a mistake, it grades its own homework. It cannot see its own blind spots. This is where multi-agent architecture changes the entire game. Instead of forcing one model to juggle a massive task, frameworks like LangGraph, CrewAI, and AutoGen split the problem into specialized roles. Think of it like an enterprise engineering team. At the top sits the Orchestrator agent. The Orchestrator does not write code. It does not browse websites. Its only job is high-level reasoning, breaking a complex project into a directed acyclic graph of small subtasks, and delegating those tasks to specialized worker agents. Below the Orchestrator are dedicated micro-agents. A researcher agent, equipped only with web search and documentation retrieval tools. A coder agent, equipped only with a file system editor and Python execution environment. And crucially, a critic or security reviewer agent. Notice how this architecture eliminates hallucinations. When the coder agent finishes writing a script, it does not deploy it directly to your servers. Instead, it passes the output across a shared state graph to the critic agent. The critic agent inspects the code with fresh context, zero memory fatigue, and strict verification rules. If the critic discovers a security vulnerability, a syntax error, or a missing dependency, it sends the task back to the coder with specific feedback. The coder fixes the mistake before any human ever sees it. This is the Actor-Critic pattern. By separating generation from evaluation, accuracy shoots through the roof. How do these agents communicate without descending into chaos? They use structured state machines and shared message buses. In modern stateful frameworks, every agent reads from a central state object and writes state transitions back to it. There are three main swarm topologies. Sequential swarms pass data down a straight pipeline. Hierarchical swarms use a manager agent to coordinate workers. And collaborative mesh swarms allow peer agents to negotiate tasks directly. When combined with protocols like Model Context Protocol, each microagent only receives the exact credentials and tools it needs for its specific job. Your researcher agent never gets access to your payment wallet. Your deployment agent never gets access to your raw database passwords. Security boundaries are enforced at the agent level. Of course, multi-agent swarms introduce new engineering challenges. If two agents disagree indefinitely, they can trigger an infinite debate loop. If task routing is unconstrained, token consumption can multiply 10 times faster than a single model. That is why modern enterprise swarms rely on deterministic guardrails, human-in-the-loop escalation gates, and strict execution budgets. A human supervisor approves the final deployment, but the swarm handles 99% of the heavy lifting. You were told that a single AI agent would do everything for you. Now you know why that single agent failed. True autonomy does not come from one giant model trying to hold the entire world in its head. It comes from specialized agents coordinating through structured systems. One AI agent is just a tool. A swarm of AI agents is an organization. Thank you for watching. Please comment and subscribe so I can work on the next content you might be interested in.